Hello learners, and welcome to a video tutorial on the effects of a dielectric in a capacitor. So here I've got just two parallel plates, one with positive charge and one with negative charge, with equal surface charge or area charge density on either side. Now if I take a dielectric, okay, let's say I take plastic or something, and I place it in between my capacitor so that it completely fills the void in between. Well, before, my capacitor was just filled with empty space. And so the capacitance of my capacitor was just equal to epsilon naught times area over d. This is the area of my plates, and this is the distance between those two plates. And then epsilon naught is the vacuum permittivity constant, and we use that because I had air in between my plates more than likely, and air does not differ very much from the vacuum of space when it comes to its permittivity. So now that I've got this plastic in here, it has a certain dielectric constant associated with it. And that dielectric constant is just shown as a K value. Now, what is going to happen here is that my dielectric has charge in it, and there's going to be an induced charge on my dielectric. So I'm going to end up with some of its positive charge going over here like this, and then some of its negative charge going over to the other side, kind of like this. Now what that does is it effectively lowers the overall E field in between my plates. Now doing this, you'll notice that the charge on my plates remained constant. It stayed the same. Well, if charge is something that is going to remain constant, if you look at the E field on here, I now only have 3 field lines, whereas before I would have had a field line going from each positive to each negative. Now I've only got 3 in a sense. So I've lowered the E field of my capacitor, or in between my capacitor. So the definition of a dielectric constant K, what it is it's a ratio of my new capacitance to my old capacitance. So my old capacitance would be this, what it was previously, whenever in this case I just had air before, and this is the new capacitance value with this dielectric inside. Now if my capacitance changes and charge remains the same, remember that capacitance is equal to charge over the voltage. Now the charge remained constant, but if my capacitance changes, so does my voltage. And we can use that to solve for relationships. So the capacitance, when you have a dielectric, is equal to K epsilon naught area over D. So what you do is you take your original capacitance and you multiply it by K to get your new capacitance. So taking a dielectric and putting it in between two parallel plates effectively increases the capacitance of a capacitor. Now when you do that, if this remains constant and I increase the amount of capacitance, well then I must lower the voltage on that capacitor. So for instance, if you can really take this relationship, and this would be the new voltage on the capacitor, and this is the original voltage divided by the K value. So there's a lot of useful relationships that you can get if you know this K, or you can solve for this K through measurement and whatnot. So I hope that helps out, and thanks for watching.